Okay, so in this video we're talking about arithmetic series. Remember, a series is just simply we take a sequence and add up all the members of that sequence. So for an arithmetic series, we have a specific rule that can be used to find the sum of that series, but it has to be arithmetic and it has to be finite. We're also going to see how we can use our calculator. So what we want to do in this example is consider the arithmetic series here. Notice that it's infinite. In part A, though, we're going to go only out to the first 30 terms, so we're going to go make it finite. Now, if you see what the pattern is, you can actually write out the first 30 terms and then just add them up. That would be kind of easy, but it might take a little bit of time. Instead, what I'm going to do is focus on that it says it's arithmetic series. Well, remember that we said in a couple videos ago that a series just takes a sequence one step farther. So I'm going to start by creating an arithmetic sequence. And the rule or the pattern that we're going to plug into is our final position is equal to our first position plus n minus 1 times our common difference. Our common difference in this particular sequence is 3 because 7 minus 4 is 3, 10 minus 7 is 3, 13 minus 10 is 3, etc. So our common difference d is 3. Here our first position is 4. So I know that for any position that I want to stop at, I can say 4 plus n minus 1 times 3. Now I'm going to go ahead and just clean this up as much as I can. I have distributive property here. So a sub n is equal to 4 plus 3n minus 3. Keep cleaning it up. 4 minus 3 is 1. So a sub n is 1 plus 3n. Okay, so now I want to find, I need to know who lives in the 30th house to find the a sub 30. So this implies that I can say a sub 30 is equal to 1 plus 3 times 30. Well, 3 times 30 is 91, so a sub 30 91. Now, but that's not what part A is asking. It's asking us to find the sum of the first 30 terms. So I'm going to go 4 plus 7 plus 10 plus 13 plus 16 plus 19 plus dot, 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 until I get plus 91. And then I'm going to add all those numbers up. So what I'm going to do now is plug into my formula that I'm given. So S of 30, because I'm going to the 30th house on this street, is equal to 30 times my fraction on top. I had 4 plus 91 divided by 2. Okay, and I can use my calculator now to clean that up. Obviously, 4 plus 91 is 95, so let's go ahead and simplify that. So this is fraction is just 95 divided by 2. Okay. And so when I type that in my calculator, I must keep that fraction inside parentheses. So what I'm going to say is 30 parentheses 95 divided by 2. And I get 1,425. So the answer to part A, is 1,425. Now, we did that by using this formula here where we just plugged in all our information. However, since our arithmetic series is now finite, we went up to the 30th house, I can also use my calculator. To do that, we're just going to say sum, sequence. We're going to use our rule 1 plus 3n, or 1 plus 3x, since it's in the calculator, x, comma, we start in the first position, or the first house, and we're going to the 30th house. Okay? So let's do that in our calculator, and if we did it right, we should get 1,425. So I'm going to start by saying second stat, go to the math menu, option 5 for sum, second stat, go to the ops menu, option 5 for sequence, 1 plus 3x was my rule, comma x for my variable, comma 1 because I'm starting in the first position of the series, comma 30 because I'm stopping in the 30th position of the series. I get 1,425. So you can either use this rule here, or if you remember how to use calculator, that's perfectly fine. Now we want to find S of n so that the sum is 175. So again, I'm going to use this rule here, plug in what I know. So I know that the sum is 175. I'm trying to find n, so I'm going to leave that alone. I know my first position in the series is 4. A sub n, however, I don't know, but I do have a rule for a sub n. So everywhere I see an a sub n, I'm going to put 1 plus 3n. And that's all divided by 2. Okay, so that's the setup. Now, this looks a little bit complicated, but 4 plus 1 is 5. So up here in this fraction, I have 5 plus 3n divided by 2. Now, we could solve this by hand. I'm actually going to do graphing, though. Remember, graphing is totally fine. So we have y1 on the left, y2 on the right. Now, before you type this in your calculator, on this fraction, you have more than one thing up top, so you need an extra set of parentheses there. Otherwise, it's not going to come out right. Also, when you graph this, where you see an n, we're going to pretend it's an x. So let's do that. So go to y equals, clear it out, 175 for y1, and then x, comma, so that's my green parenthesis on the outside. Now my purple parenthesis for the top, 5 plus 3n, or 3x. Close my purple parenthesis, divided by 2, close my green parenthesis. It's very important you kind of talk yourself through that since there's a lot of extra parentheses that are needed for this problem. Otherwise, it's not going to come out right. All right, so now I only see one thing, so I probably need to zoom out. I still only see one thing, so I'm going to zoom out. Still only see one thing, so I'm going to zoom out. And so now, remember our original shape that we saw in the graph was a U shape, so that this line that's going to cross is actually going to hit that U in 2 spots. My calculator vanished, let me get it back. So there's going to be a point of intersection on the left and a point of intersection somewhere on the right. So I need to find both points of intersection. So second count, option 5, first curve enter, second curve enter, yes. Well, my first point of intersection is negative 11.667. Well, a couple things that are bad about this. N has to be positive. Also, N has to be a whole number. So since it's negative and since it's a decimal, it doesn't work. Second count, option 5, first curve enter, second curve enter. I'm finding the one on the right now. I get x equals 10. It's positive and it's a whole number, so everything's good. So for part B, the answer is n equals 10, exactly like we were supposed to find. And that wraps it up for arithmetic series. We're going to jump into geometric sequences next.